How's it going? This is our Simio presentation. We're King Louise.
The purpose of the Estadio Simio Matchday Analysis is to work alongside the Simio Soccer Committee using the information and data provided to ultimately develop a new operational strategy for the upcoming match. To achieve this objective, it is best for the given data to be fitted into distributions to be able to model the system accurately.
So looking at our assumptions and limitations, we didn't really have too many assumptions or limitations. So looking at the assumptions, we just kind of assumed that all the concessions, merchandise, bathrooms are only going to be used in their respective sections. So we just kind of assumed that the fans wouldn't be leaving their section just to make it easier as far as modeling the system. That way, um, we kind of like knew how many fans were going to be going into each concession or merchandise or bathroom, for example. And then as far as limitations, we were limited by fans reneging from the lines and entering new lines right away. So it limits our abilities to kind of track the fans once they're up out of the seats. So once they would leave their seats and say we knew they went to merchandise, we wouldn't really know where if they had left that and just went right back to somewhere else. We couldn't really keep track of that. But the only way we were able to keep track of it was looking at the actual results of how many people went through. And then fans are also constantly returning to the stands.
The process was we determined the distribution from the data for each gate, concession stand, merchandise stand, and bathroom. So we had to verify the model. So we ran the simulation for one or the duration of one soccer game, and then the simulation results were compared to the data to ensure that the interarrival times and percentages we used were accurate. Then we also had to validate the model. So again, we checked the simulation result, and by doing so, it seemed that completed all the requirements set by the project problem statement.
So looking at our overall data analysis, we got a ton of data from Simio. So we are looking at calculating overall arrival rates and service rates for each respective section. So gates, merchandise, concessions, bathrooms, security at the gates, what people are going to do at those concessions, for example. So we calculated that data for gate arrivals and arrivals at those different areas. And then from that, we were able to fit them to their best distribution to kind of see what the data looked like and what we were going to be working with. We provided data for calculations of probabilities for each of those sections. So, for example, purchasing a certain number of concessions or merchandise, we were able to calculate all of our probabilities out for if they're going to buy one hot dog, two hot dog, or like one bottle of water, three bottles of water, for example. And by having it fitted to the distribution, we were able to do when we input it, we're able to talk about or we're able to input the code as the distribution and then the probability that those distributions would kind of like be occurring. Um, Other ones are just going to the bathroom or just entering through a certain gate or going from their certain gate to their respective section. So not all fans came in the gates closest to their section. So some of them would come into gate A and then completely go across the stadium to where the other gates were or to where their section is. So we had to calculate the probabilities that they would go to those areas. And then overall service rates, we just adjusted the service rates to fit arrival rates by adjusting how many servers were at each station, and then that would help us efficiently serve our customers. We attain these service rates through verifying times it took customers on average to move through the systems at each server.
For the initial model development, we decided that it would be best to utilize 5 different models within the one Simio file, and each of the 5 files represents a different seating section. So for an example, if we're looking at the general public section, we used one model and we have all 4 gates. So 13% in gate A go to the general public. Therefore, we had 13% of people coming in from gate A go through the system, and then the remaining 97 or 87% went to a sink. And this would be done for each of the 5 models within the file for each of the different seating sections. And for each of those gates, we used the different data distributions for arrival times. And we also did that for the concession stands, merchandise stands, and restrooms at each respective gates or each respective sections specific stands.
So to start with an example to explain how we did our model logic behind it, we will start with the concessions. So in the concessions, we divided each type of item they could buy into a server of its own, because each time each item they will buy, it will take different amount of time to prepare and to sell it. In this case, we have soft drinks, beers, bottled water, fries, hot dogs, pizza slices, and hamburgers. They all have a probability starting from when they get out of their seats to go to any which of them. There's a slight probability, and each time they go from soft drinks, they will again go through the logic of deciding, okay, will I go to bottled water or would I go straight to hamburgers? But to make it easier for us, once they pass a server, let's say they go from soft drinks to bottled water, they won't be able to go back to beers. They will have to loop back around the system all over again. For the bathrooms, we made a 60-35% splitting between males and females, and there is also a 50-50 chance, either male or female, that they won't go to the bathroom at all. They will stand out of their seats, and then they will decide not to use the bathroom. And so for our results, we multiplied them all into 3 games to make it easier to see and compare to the raw data given. So for the total people, we had 4,300 people, which we would have had almost around 4,500 people. We had a difference of 115. And for the restrooms, both for male and for female, we had a difference of 177 and 265 respectively. This might be because, again, we did not take into account people going from other seated sections into concessions that weren't the nearest one to them, or to the restrooms nearest to them. So there is where the slight differences, as well as we had less people overall in the seating section. For our concessions, we had a difference of 560 items sold. This is the total amount of items sold, not specifying if it's 1, 2, or 3. This is just the amount of people who bought items in it. We had a difference of 560 again, maybe because people from other seating areas went to these concessions to buy their items instead of the ones nearest to them. And for the merchants, we had 86 t-shirts sold over